Hey, good evening again. Welcome to Free Teach, and this is looking at how to use the CAS to solve geometric growth and decay problems. So get straight into it. Let's have a look what we've got here. It's asking us how many years will it take an investment of $2,000, paying compound interest at the rate of 6%, to grow above $3,000. Okay, and wants it to be correct to the nearest year. Okay, all right. So we've got investment, a value of V0. I'll change my pen color. So we've got a V0 of $2,000. We've got little r of 6%. And we know that the value after n years, okay, so we want to be $3,000. Okay, so using all that info, we want to put that into our rule first off. So we know that we want 3,000. Let's get rid of that to start with. Let's take it back a second. So our rule's Vn is equal to R to the power of n times V0. All right, we've stated that Vn's 3,000. R, big R that is. Big R is going to be, so it's paying compound interest. So it's going to be growth. So it's 1 plus R over, sorry, let's make that 6 over 100, which is equal to 1.06. So 1.06 to the power of n. Now, n is what we're going to be wanting to find because we know that V0 is $3,000. Sorry, where am I going with that? V0 is not $3,000. V0 is $2,000, like we've got over the left there. Okay. Now, it says we are using the CAS to do this. Okay, we don't have to do any funny thinking. We aren't great unless we're using logs at finding the value of an index. So we're going to use a solve function on the CAS to punch all that in. The CAS set up over here. So we're going to open your solver. Solve $3,000 is equal to 1.06 to the power of n multiplied by $2,000. Close our brackets. No solution. Why is there no solution? Because I didn't tell it what to find. Tell me what n's going to be. And n is 6.958 years. Well, 959. Now, we said earlier that it wants it to the nearest year. Okay. Now, lots of these problems, it'll ask you to state it in context. So, for instance, this one, our answer is 7 years, is how long it'll take the investment to grow above $3,000. If it didn't ask that, and it said, maybe it just says, how long will it take for the investment to grow to $3,000 correct to a year, for instance, you would still, and it gave you an answer, just say it gave you an answer of 6.3 years. You really shouldn't be rounding that down to 6 years because you're not at $3,000 of that 6 years if that was in fact your answer. Okay. In the context of the question, you should be saying it's going to take you 7 years, for instance. So I hope that down the track that might come up where you're asked to answer it in context. If it takes 6.3 years to get to $3,000 and you're asked for it, the answer to just be in years to the nearest whole year, then your answer should be 7 years, because it won't be until that 7th year that you've made the $3,000. The $3,000 won't be made if you rounded it down to 6.3 years. Okay, so hopefully that's not too weird. Next question. Industrial weaving company purchased a new loom. I'm going to use a highlighter for this just so I can... Let's pick that one. So we're doing a new loom cost $56,000. Would want to be turning out some decent track pants. It has an estimated value of $15,000 after 10 years of operation. If the value of the loom is depreciated using a reducing balance method, what's the annual rate of depreciation? Okay, so we're looking for the annual rate of depreciation. So this has a little bit more in it. We know that V0 is $56,000. We know that VN is $15,000. And that figure was when N had the value of 10 years. Now, what it's asking for though is the value. So we don't know what R is, okay? Because what we're actually looking for is the annual rate of depreciation, okay? Okay, big one there. Annual rate of depreciation is our little r. So we know that our equation looks like this. Vn equals r to the power of n times VO. Okay. Now we know a few things about this. So because we're trying to find, at the end of the day, the little r, I'm going to expand out our rate of change, so big R, into its components. All right, so we know that that is all made up of one take, because it's a depreciation problem, one take R over 100, all to the power of n times VO. Okay. And it's just going to make it a little simpler down the track. So now we're going to substitute in everything we know. We know that it's worth $15,000. One take R over 100 to the power of 10, and that's multiplied by 56,000. Okay. And now we go into our solve function on the CAS. All right, punch it in over here. So solve 15,000 is equal to, pop this in brackets, bracket 1 take let's just call it R over 100 bracket, that is to the power of 10 multiplied by 56,000, and we're looking for R. Okay, solve, and we get two numbers there. Okay, now out of the two numbers, we take the smallest one. Okay, we always take the smallest one. If you think about it logically as well, to suggest that you have a rate of change. So this one. So if we had a rate of change of 187, that's saying that's 187%, which is suggesting that it's dropping by more than the whole value of the loom per year. So there's no way we could have, after 10 years, a value of $15,000. All right, so that's just the logical way of explaining it without going into the indices and the rest of it. Okay, so our value for our loom, not draw anything there. So the value for the loom comes to, can't see my calculator. So R is equal to 12 point, so it says 1 decimal place, 0.3% is the rate of depreciation. Okay. Hope that's all good, gang. Have a beautiful night, beautiful afternoon, whatever it is, and we will see you next time on Free Teach. Thanks, guys. Like, subscribe. Say hi to your mum. Rove McManus. Reference. Happy days, gang. Bye.